Other summary measures. Ratio. Next, we have ratio. The ratio of a number x to another number y expresses the size of one measure x with respect to the size of another measure y. The ratio is a comparison of values of two different groups. For example, ratio of men to women in this training course. Generally, it is written as x:y and read as the ratio of x is to y. It is recommended to write official statistics as ratios using either the base of 1, the base of 10, the base of 100, 1000, and so on. Here are some things to note when dealing with ratios. First, the measure y in the denominator is called the base. Next, when the measure x is divided by the measure y, the relationship that x bears to y is then expressed as a ratio to 1. Lastly, the numerator, or the value above, is usually greater than the denominator. Now, we have here some guidelines on ratio. When we compute for ratios, you divide the count of one group by another group, and you end up with a decimal value. However, you want to avoid decimals in ratios, as you usually are dealing with counts, and recall that counts are in whole numbers. Let's say that 1.4:1 is a ratio of chairs to students. What is 1 chair? 1 chair and an armrest? A backrest? One option to improve the interpretation is, we could change the base of our ratios using the base of 10, 100, 1000, etc. instead of 1.4:1. We can now say that we have 14 chairs to 10 students, or 140 chairs to 100 students, meaning that there is a surplus of 4 chairs for every 10 students. Another way to avoid decimals in our ratio is to round them off into whole numbers. Like instead of 367.89:1, we will have 368:1. These are the two options recommended to avoid decimals in our ratio. But before jumping off to rounding off your ratio, the deciding factor is how important the decimal value is. Consider rounding off our first example. Instead of 1.4:1, we will have 1:1. But we don't have the same ratio of chairs to students. Initially, you had an excess of chairs, and you want the final ratio to reflect that. With a 368:1, we say, for every 368 citizens, there is 1 policeman. And reflecting the decimal value of 0.89 may not matter as much, so it is okay to round it up. Though, you have to be very extra careful in choosing the best option to remove the decimals in your ratio. Another guideline to remember when computing for ratios. The resulting ratio must summarize the initial information. For example, a certain division has 21 females and 9 males. What is the ratio of males to females? To get the ratio, divide the count of one group by the other group. The resulting value is the ratio of the value of the numerator to the second group, expressed initially as a base of 1. So 2.3 is the value for females, and will have a base of 1 male. Now, do we round it off, such that we have 2 females for every 1 male? And the answer is no, because there are more females than just 2 for every 1 male. So, do we change the base to 10 instead? Meaning, we will have a ratio of 23:10, such that we have 23 females to 10 males. Is this correct? And the answer is, this is incorrect. Why? Because this is no longer reflective of the initial counts of employees. Remember our guideline. The resulting ratio must summarize the initial information. For this particular example, another descriptive statistics that we could use is the percentage. So we could highlight the percentage of the males in the division. We have provided a lot of statistics for you to choose from. This does not mean, however, that you must use all the statistics in your arsenal. Instead, you must choose the statistic that would best represent and summarize your data. Let's have an example, this time on sex ratio. We have here a table. Table 2, projected population by region and sex in the Philippines in 2019. So, we have here all the regions of the country. Then, we have the total projected mid-year populations, as well as the breakdown of males and females. We also have the sex ratio for every 100 females. The sex ratio is computed as follows. You simply divide the number of males by the number of females, then multiply it with a fixed base of 100. If we are to compute for the sex ratio of NCR, then we divide the two values given here and multiply it by 100. And we will get 98. This is interpreted as there are 98 males to 100 females in NCR. Now, this interpretation is simple and can be extended down even at the LGU level, as long as you have the sufficient data on the number of males and females in your locality. Let us have another example. This time, we look at the dependency ratio. The dependency ratio is computed as follows. The number of dependents divided by the number of people in the economically productive ages, multiplied by 100. When we say number of dependents, those are the people aged 0 to 14 and 65 years old and older. Then, we divide it by the number of people in the working age of 15 to 64 years old, multiplied by 100 as the base. Instead of computing for the ratio, we have here Table 3, Dependency Ratio by Region in the Philippines in 2010. And this is provided by the PSA. So, let us go ahead and interpret the dependency ratio for the Philippines. There are 58 dependents for every 100 people in the economically productive age group of the Philippines. Ideally, you would want a lower dependency ratio, because a higher dependency ratio would mean that you are overburdening those that are working. So again, you can also generate the dependency ratio of your LGU so long as you have the data on the number of dependents and people in the labor force in your area. This would come in handy if you want to determine if your citizens are within the working age or if there are considerable number of dependents in your LGU. You could create programs to help provide financial aid for the dependents in your area in case you have a high dependency ratio.